So starting off, we have our auxiliary port input, and we have combined our left and right outputs so that the signal is stronger. The ground output from that is actually grounded here. Now the left and right inputs are then put directly into a capacitor to filter out some of the signal that comes from there, a lot of the noise, and then it goes directly into a division between two parallel sets of resistors. Now the first set goes up to the microphone, where we have a potentiometer with 9 volts in and 0 volts as the base. We can change that to determine how much voltage goes through the microphone, and we can have the option with this setup to either combine the signals of the voice and the auxiliary, or to just use one or the other individually. Now those signals, they meet at this node right here, and then they enter our op amp right here, and they will enter with help from a voltage source. They will come out to our bias T, and we've used a 220 microfarad capacitor. The purpose of that is because it's a large capacitor and it filters out a large amount of noise. Smaller capacitors don't do as good of a job. Now the bias T consists of an inductor, which keeps a lot of the current going in the right direction, and then it filters into this potentiometer where we have 9 volts again coming in, and we have 0 volts coming in at the base. And what this allows us to do is actually change the intensity of our laser. From there, we'll follow it back down this way, and we have a 100 ohm resistor in series with our actual laser, which is connected right here. So this allows us, we hold the button down and we can get a signal from the laser.
This is the schematic that we used for our receiving circuit. I'll talk about that in a second, but this is what it looks like on the proto board. We used an op amp and a potentiometer to deal with our input voltages. The potentiometer is used to adjust the voltage that's going into the op amp through the negative terminal, and through the positive terminal we have a positive 9 volts. And so we used ground here because we don't have any way of using a negative 9 volts, because our materials were limited to two 9-volt batteries, one for each of the circuits. So this potentiometer sends a smaller smaller voltage out through here and into this node. This capacitor prevents any backflow into the solar cell, and this voltage continues to carry up into here, where the voltage from the solar cell and the potentiometer will meet and go through our op amp. And the op amp has a negative feedback with a very large gain. And originally the gain that we had was much larger. It was around 10,000. But because it was too high, we ended up getting clipping from the noise, which basically we'd get only part of the noise coming through, and it would skip. And then we tried turning it down more, but when we turned it down too far, we didn't get any output from the audio whatsoever. So after playing with it for a while, we ended up using a value of around 1,000 for gain, and that worked perfectly with all our values, so that we got a decent sound. It still came out staticky, but it was better than what we had prior. So now I can trace through the physical proto board instead of looking at the schematic. So we start with the solar cell, which works into the resistors, this is the resistor in parallel to the solar cell. Then we have our two capacitors, which were in the loop here. And currently we don't have the batteries attached, but they would come in through here, work our way down into the potentiometer in the op amp. You can see our 10 ohm resistor here, also our negative feedback with our 10K resistor here, so that's 1,000 gain overall. So this is our receiving circuit.